So for the first topic, I want to introduce several methods to calculate the limits. So there are six basic methods to calculate the limits. First one is factorization, second one simplification, third one build up the fraction, fourth logarithm application, the fifth L'Hopital's rule, the sixth divided something numerator and denominator. So latterly, I will use these six methods to solve six past exam questions. And now I just short introduce these six methods. So the first one, factorization, it means when you see something like a squared minus b squared, and easily you can factorize it by a plus b and a minus b. And the second simplification is really easy. We'll see the fraction a times b, and here is an a. You can know, so cancel these two terms out. So what we left is b over 1. The third one, build up the fraction, something like x plus and square root x squared plus x, for example. And this one you can say it is it could be build up the fraction something like this, minus square root x squared plus x, and then divided by the same term. So you can say here this one is equal to x squared minus x. So the two terms cancel out, and we just left the negative x. This one is quite useful. And the fourth one is logarithm application. It means when you see something like x to the power of x, so two variables together, then it's not what you're familiar with. So when you want to calculate the limit of this thing, just set it to L and then take the log. Log L is equal to x times log x. So everybody knows that the power, when you have the log sec, the power on the equation could be shift to here. So the fifth L'Hopital's rule, this one is really pivotal. So the definition is, suppose limit x approaching to a, fx is equal to 0, and limit of gx is equal to 0, or the limit of fx is negative or positive infinity, and limit gx is also the positive or negative infinity. Then this one, which means we have an indeterminate form, which represent by 0, 0 or infinity, infinity, no matter it is positive or negative. Therefore, we have limit x approaching to a, fx over gx is equal to the limit x approaching to a, fx prime and gx prime. This is just the first derivative on the numerator and the denominator. If you're not familiar with the L'Hopital's rule, go check the chapter 4.4. You have to know this because this is very important. And also sometimes the L'Hopital's rule are written with an S, which is the L'Hopital's rule, but this S will not pronounce, is silent. So L'Hopital and this, they are the same thing. The last method, dividing something on numerator and denominator. This is easy to understand. Why is that? A very little example is 1 plus a and 1 plus a squared. What we do is we divide it by a, and here is a squared probably, a, and then a squared 1 plus 1. So if a approaching to infinity and all these are 0, just 1 left. So the numerator is 0, all the term is 0. And so sometimes these 6 methods need to be mixed up. And for a question, you may see several methods working together to solve the question. So in order to have a very clear idea, let's take a look at several questions.